My name is Paul Avery, and I am a Drives Product Training Engineer with Yaskawa America. I will be your instructor today as we go through this e-learning module. This e-learning module will discuss Yaskawa's G7 AC drive. We will cover some of the features and functions that make the G7 the ultimate performance solution. The G7 offers the most digital inputs, digital outputs, analog inputs, and analog outputs of any Yaskawa drive. The scan time for the drive programming is half of previous Yaskawa drives, which leads to faster drive performance. The G7 has the capability to be integrated into most of today's cutting-edge communication networks. An increased speed response bandwidth will give the G7 performance approaching that of servo systems. Special software options such as DriveWorks EZ and custom case software allow the G7 to be customized specifically for an application. A new open-loop vector solution gives the G7 the capability to perform sensorless torque control and torque limiting. Lastly, the 480-volt version of the G7 offers 3-level control that will reduce or eliminate long cable issues, reduce bearing failures due to bearing currents, and limit common mode noise, while also reducing the effect of audible noise. 12 isolated digital inputs makes the G7 easy to integrate into existing or new applications. The 10 multifunction inputs, as well as the 2 dedicated start-stop inputs, are configurable as either syncing or sourcing inputs that can be powered internally by the drive or externally via a customer-supplied 24-volt DC power supply. The drive comes standard with 6 digital outputs, with more than half of the digital outputs on the G7 actually being relay outputs. The dedicated fault relay is a normally open, normally closed Form C relay. 3 other Form A relays have their functions set by the user. 2 extra open collector outputs are also user configurable. The G7 offers the functionality to accept or source a pulse train. This makes the G7 simple to integrate with PLC pulse train cards and makes master-slave applications extremely simple and cost-effective. Multiple analog inputs and outputs provide further drive control possibilities. Both the analog inputs and analog outputs offer both 0 to 10 volts or 4 to 20 milliamp solutions. Finally, the G7 has built-in RS-485-422 capabilities. The Modbus RTU protocol is recognized via the RS-485-422 terminals on the control terminal block, with the option to select a terminating resistor, if needed, via a selector switch. Option boards increase the G7's communication and I/O capabilities. Optional network communication boards include an Ethernet solution using Modbus TCP/IP protocol, a DeviceNet board, a Profibus board, a Modbus Plus board, and a LANWorks board. Additional I/O includes a high-resolution analog board that will replace the drive's standard analog inputs with high-resolution 14-bit or 13-bit plus sign analog inputs. Using case software and the optional high-resolution board, it is possible to use both the drive's standard analog inputs and the high-resolution analog inputs for a total of 6 analog inputs. An optional analog output card provides 2 0 to 10 volt DC analog outputs as either 8-bit or 12-bit resolution analog outputs to go with the drive's standard analog outputs. The need for additional digital inputs are met by option cards that provide either 24 volt or 120 volts AC inputs to add to the drive's standard digital inputs. An optional digital output card will bring the drive's output count up to 6 relay outputs and 10 open collector outputs. The speed response bandwidth of a drive refers to the drive's quickness in tracking rapid changes in the frequency reference or instantaneous changes in the load, also known as shock loading. The speed response of the G7 in both the open-loop vector and closed-loop vector modes has improved over what was available previously from the G5 drive and the F7 drive. This slide shows a scope trace of the G7 responding to an instantaneous change in the frequency reference, or a step change. A change of 60 RPMs is achieved in approximately 25 milliseconds because of the G7's ability to rapidly achieve a very high torque reference. This slide shows how the G7 responds to a shock loading situation. The scope trace shown details how the load suddenly changes and the G7 responds with a rapid change in torque reference and a motor current that more than triples. The end effect of the shock load is a small dip in motor speed that never exceeds 8 RPMs and is over in approximately 0.3 of a second. Though not at servo response capabilities, the G7 speed response closes the gap between the AC drives and the servo drives. Both vector modes of the G7 offer a 4-quadrant torque limiting function. While either motoring or regenerating, the G7 will precisely cap motor torque at a specified level regardless of the torque demanded by the load. The scope trace shows the motor speed dipping as the G7 limits the available motor torque to a level below the torque required to produce a constant speed. Once the load torque drops below the level of the torque limit, the motor speed returns to normal. The upshoot of the torque limiting function is that the G7 can protect the powertrain equipment, such as couplings or gearboxes, or the application itself, from forces that can damage or destroy them. The G7 offers improved open-loop vector performance due to a sophisticated dual flux observer used by its open-loop vector 2 mode. The new flux observer offers better speed regulation without feedback than was possible before. Precise speed estimation leads to some significant performance achievements such as smooth motor operation without cogging at speeds even below 1 Hz, an effective speed control range that is double that of the open-loop vector mode of the G5, speed response that is 3 times as fast as the open-loop vector mode of the G5, the ability to produce 150% of the motor's rated torque at speeds as low as 0.3 of a Hz. Also, the open-loop vector 2 mode can recognize motor speed deviations even without the use of real-time feedback. Like the closed-loop and open-loop 1 vector control modes, 4-quadrant torque limiting is also possible with the open-loop vector 2 mode. Another benefit of the improved flux observer used by the open-loop vector 2 mode is the ability to perform torque regulation without feedback. The open-loop vector 2 mode will accept an external torque reference and a speed limit input to perform torque regulation over the 6 to 60 Hz speed range. Various applications will benefit from using the open-loop torque regulation without the need for the extra costs associated with supplying motor feedback equipment. Yaskawa has released a special software system called DriveWorks EZ for use exclusively with the G7. DriveWorks EZ is a graphical icon-based tool that can be used to customize drive operation. DriveWorks EZ is actually 2 components, special firmware that is loaded into the G7 and a PC program that is used to create and monitor custom drive operation. With DriveWorks EZ, special drive functionality and sequencing can be programmed into the G7 that customizes the drive for the application. Users of DriveWorks EZ can create their own programming after being trained by Yaskawa, or they can use pre-written Yaskawa templates. A DriveWorks EZ program plus data is called a project. The screenshot shown is a standard layout of the DriveWorks EZ. The main window is called the Program page, and it is the canvas that the custom functions are created on. A full project can contain up to 8 program pages. To create a custom function, icons are dragged from one of the many block toolbars and placed on the Program page. Clicking between the icons causes connections to be made between them. To change between the different pages of a Project Navigator window is displayed. Changing between the pages is as easy as clicking on the page icon for the needed page. By clicking on the individual icon block on a page, the Properties window will show specifics of the chosen block and allow for a customization of the function block, such as a gain and a bias for an analog input. Available to the G7 user is custom software called Case. A G7 with Case software creates a unique solution to many of today's more challenging applications. Case software can be used to customize the G7 to an extent not even possible using DriveWorks EZ. Standard case packages can eliminate the need for external controls by putting the functionality of the external controls within the drive programming. Yaskawa maintains a library of pre-written application solutions using Case for such industries as the packaging, textile, paper, and automotive industries. Another feature found only in the G7 is the feed-forward function. The ASR, or automatic speed regulator circuitry, is a PI function that regulates drive output to achieve accurate speed regulation. The feed-forward function will isolate the ASR's reaction to motor speed errors caused by frequency reference change from reactions to motor speed errors caused by the load changes. By separating the 2 types of motor speed errors, the ASR with feed-forward can more effectively compensate for the errors without the use of overly aggressive ASR gains. In the case of a stepped change in the frequency reference, the ASR will cause some overshoot and ringing of the output speed the way a normal PI loop will. The feed-forward function compensates for integral windup in the ASR and also variations caused by the motor's inherent time constant to keep the output speed from overshooting the frequency reference. Use the feed-forward function featured in the open-loop vector 2 and closed-loop vector modes of the G7 as a potential solution to many positioning applications. The G7 drive is the first commercially available drive to offer 3-level control on its 480-volt models. On the next few slides, we will cover the benefits of using 3-level control, such as reduction of motor surge voltages due to long motor cable lengths, reduction of motor bearing currents to levels that will not destroy the bearings, reduction of leakage currents synonymous with the common mode noise, and reduction in the effective audible noise of a motor caused by PWM switching. The term 3-level control derives from the fact that each of the drive's output phases has 3 different voltage levels that it can source: 0 volts, half the bus voltage, and the full bus voltage level. A standard 2-level control can only source full bus voltage or no bus voltage. The capability to source a third voltage level comes from the use of 6 extra output transistors and 2 more bus capacitors. The extra hardware is utilized to create a midpoint that is used to source only half the bus voltage when only that voltage is necessary to create the appropriate output voltage waveform. Reflected wave is a phenomenon whereby voltage pulses, such as those created by PWM drives, are reflected back to the drive due to the characteristics of the cable coupled with the very high dVdt of the pulses themselves. When the reflected pulse coincides with a new pulse, the effect is additive and the motor winding is subjected to peak-to-peak voltages that are more than twice the level of the drive's DC bus. These peak voltages can damage or destroy weaker motor insulation. In the past, the only solution to the problem of reflected wave was to add costly output reactors or dVdt filters. The G7 drive's 3-level control greatly reduces the effect of high dVdts by outputting the voltage pulses in steps, which in turn suppresses the surge voltages seen by the motor windings without the need of any external equipment. The graphics on this slide demonstrate the theoretical beneficial effects of 3-level output. With a conventional 2-level output, the motor terminals may see voltage peaks 3 times the amplitude of the DC bus. But by using the 3-level control, a suppression effect can limit the voltage measured at the motor terminals to only twice the amplitude of the DC bus. The clear benefit of using the G7 is that motors with weaker insulation, such as general-purpose motors, will survive much longer without insulation failures when driven by a G7. In actual laboratory tests against a competitive 2-level drive, the worst-case surge voltages of each drive were captured and compared. The competitive drive was a recently introduced product with reflective wave software enabled. The competitive drive has a measured peak-to-peak voltage value of over 1700 volts, as compared to the G7, which has a peak-to-peak value of only 1230 volts. This data shows that the G7 generated peak voltages 28% lower than that of the currently offered 2-level drive. Motor winding failures, such as that shown in the photo, are much less likely when using the G7. Another solution to motor failures offered by the G7 is to the failure of motor bearings caused by bearing currents. Common mode voltages caused by capacitive coupling allow currents to flow from the rotor to the ground via the motor shell. This path takes the current through the motor bearings, which causes pitting and fluting of the bearing race, and also degrades the bearing lubrication. Currently, the only solutions to the problem of bearing currents involve costly output filters or customized motor construction. The G7, with its 3-level output, reduces the chances of bearing currents by limiting the common mode voltages in the motor. Hence, no extra equipment or expensive motor construction is necessary. Again, laboratory tests against a competitor's 2-level drive show that the G7 produces beneficial effects that are not possible with the standard 2-level drive. The tests show that the measured motor bearing currents are reduced by over 50% when compared with the competitor's 2-level drive. It is because of the G7's stepped output voltage waveform that the dVdt effects that contribute to common mode voltages are reduced and make the G7 the clear choice for increasing the life of a motor. Capacitive coupling again plays a role in another potential problem caused by common mode voltages. Capacitive coupling between the ground and the motor leads will cause leakage currents to be induced on the ground lead. This noise caused by the leakage current may disrupt the operation of sensitive equipment that uses the same grounding point as the motor and drive. Again, solutions to this point have involved money spent on expensive and complicated external equipment like common mode filters. Because of the way that 3-level control reduces dVdt effects by stepping the output voltage, the common mode noise at the drive output is reduced to levels below that of 2-level drives and may not require external equipment. Laboratory tests again prove the superiority of the 3-level controlled G7 to that of its 2-level counterpart, this time in regard to common mode noise. Common mode currents, which I have also referred to as leakage currents, are almost cut in half by using the 3-level output voltage waveform. Limiting common mode currents brings about reductions in common mode noise, which in turn makes it safe to use sensitive equipment around the drive. The last topic related to three-level control that we will mention is the effects on audible motor noise. It is no secret that operating a motor with the PWM drive will produce significant levels of noise from the motor that can annoy and irritate some humans that are working around the equipment. The only standard way to decrease the audible noise is to increase the PWM switching frequency out of the range of human hearing. Increasing the switching frequency is not possible with most larger motors and will probably increase heating in the drive itself. Another solution to the audible noise problem that came from the drive industry was referred to as white noise switching. White noise switching would modify the characteristics of the noise to make it more acceptable, but did not reduce the level of noise appreciably. The solution offered by the three-level G7 comes from a unique switching pattern that makes the audible noise shift to a frequency that is twice the actual switching frequency and is out of most humans' hearing capabilities. The G7 drive is the most unique and progressive AC drive available today. It offers a premium selection of I/O and network options. It has the programming power and response capabilities to make it a solution for even the toughest drive applications and even some simple servo applications. The one-of-a-kind three-level output capabilities of the 480-volt version eliminate the need for expensive external equipment while also guaranteeing a long life for all equipment used with it and around it. When comparing the G7 against other industry solutions, remember to include all the extra equipment that they will require that the G7 will not. You will be glad you did. Thank you. Thank you for attending this Yaskawa America e-learning module. We greatly appreciate you taking the time to learn more about our products. If you would like additional training, please contact us through any of the methods above. Thanks again, and have a great day.